Good morning, everyone. Sorry for the late. Good morning. Yes. So, topic is chemical equations. In the term, yesterday we have completed balancing the chemical equations, right? So, I'll remind you again that stepwise balancing the reaction between the hydrochloric acid and sodium chloride. The very first step is writing the chemical equations, right? Skeletal equation or primary equation using the symbols and formulas, right? So we will write the formula HCl plus Na2CO3 gives you NaCl, H2O and carbon dioxide. This is the equation. Then second step is checking the count of individual atoms and noting them in the table. So make a table with the headings atom, number of atoms on reactants and product side. So individual atoms, just you need to follow only one direction towards reactant side or maybe product side. So here look at H and Cl, Na, C and O. How many? 1, 2, 3, 4, 5 atoms are there individually. So that 5 atoms names I will write in the table. But no need to check them on a reactant side. So product side, same number of atoms, same type of atoms will be repeated. No new atoms produced in a chemical reaction. So that is the reason here. Then checking that individual count of elements here, right? Hydrogen on LHS side, only one. Next, chlorine, LHS side, 1. Sodium, subscript is there, 2. Carbon, no subscript. That means only 1. Oxygen, 3 is the subscript, so 3. On RHS side, Na, only 1. Sorry. Here, hydrogen. Hydrogen is 2. Then chlorine, 1. No subscript. Next, sodium, no subscript means 1. Next, carbon, no subscript, 1. Oxygen, subscript is there and it is repeated twice. So 1 is in H2O, 2 are in carbon dioxide. So 1 plus 2 equal to 3. So like this, we can write the count. Then here, after counting them, you need to select the large numbered formula, right? Large numbered formula is Na2CO3. Right, Na2CO3. Here, if I take this, what happens here? Chlorine count is going to be vary. So that is the reason to select another compound here, HCl. Right. So I'll put 2 ice coefficient before HCl here. Then what happens if you put 2 ice coefficient before HCl? Hydrogen count is balanced. Okay. Then what about chlorine atoms in that HCl? Disturbed. So that count is changed. LHS side, I got count of chlorine atoms, ice 2 here. So RHS side also, I need to change it. So we'll put 2 ice coefficient before NaCl in the next step. Then what happens? Count of NaCl changes into 2 Na and 2 chlorine atoms. Right? Then check the other. Here, oxygen count already same. Carbon count already same. Right? So that's why I selected HCl first. Okay. So here, checking your equation. Checking your equation. So it is balanced. Okay, once again, counting that. Hydrogen count is 2. After changing the coefficients before the formulas. Final equation in the step 4 that I am using for checking in the step 5. So step 4 equation, checking in the step 5. Chlorines, 2. Sodium, 1, 2 left side. Carbon, 1. Oxygens, 3 left side. Then RHS side. RHS side, hydrogens, 2. Chlorines, 2. Because coefficient is there. That coefficient here and chlorine atom is here. Then check its subscript. Then take the product of coefficient and the subscript. So 2 into 1, 2. Like this, I'm getting here. Then sodium count 2, coefficient. Then carbon count 1, no change. Oxygen's count 1 plus 2, no change. So like this, we can balance the chemical equation stepwise. So it is asked for 4 marks or asked in long answer type, right? No choice to ask in the long answer type. Maybe you will get maximum in 4 marks question only. If that is asked for in a 4 marks question, you need to write stepwise. Is it clear? Just to go for quick reaction. Okay. So next, we have few examples for the balancing. Example 1, 2, 3 are given in your textbook. What they are here? Hydrogen and oxygen combination produces water. So is it a balanced equation or not? Tell me, is it a balanced equation or not? How do we decide? Just checking the individual count of atoms. For that, we need a table. So make a table like this, elements and number of atoms on a LHS side or HS side, or as we written in the previous example, that same table also you can follow, right? Any what a heading in the table, columns, correct only, right? So elements individually, just left side only I am depending, right? I am depending on a reactants only. Here, individual atoms, hydrogen and oxygen, only 2 atoms are there, right? Then RHS side, same, only 2 atoms in H2O, hydrogen and oxygen. So don't go for RHS side. Okay. For naming the elements or notice atoms in the table based on only reactants or products. Okay. Always from left side. Okay. Then counting that. Here in hydrogen, I have 2 atoms of hydrogen, H2. Here in H2, I have 2 hydrogen atoms. Next, 2 oxygen atoms there, where in an oxygen molecule. Next, RHS side. Here, you can name that where they are present. That number you can represent like this also in hydrogen, in oxygen. It's not a mistake, right? It is compulsory means you can write. Otherwise, if you are clarity where they are, no need to write them. RHS side. In H2O only I have 2 hydrogens. In H2O I have only 1 oxygen. So that we can represent. Is it a balanced equation? Check that table. Is it a balanced equation? No, it is not a balanced equation. We have individual atoms count difference here. See here, oxygen 2, oxygen 1. So reactant side, product side count is different. So it is against the law of conservation of mass. To satisfy that, I need to change the count of oxygen atoms in H2O. Suppose if I change like this, are you accepting me? Now it is balanced. I balance it like this. Is it correct one? Abhinay, what's the problem? What's the problem? Abhinay, answer me. What's the problem? I balance it like this.
So we can't add the atoms.
What happens if I add?
It forms another chemical formula.
Very good. Here H2O and H2O2 are different. They are different in their characteristic properties. If you add any atom to the, number, that atom added by number to the formula, it changes its composition and characteristic properties. So that is the wrong method here, right? So don't write any number in its subscription or don't add into the formula. Just you have option to change coefficient. Okay, to change only coefficient. So here simply 2 required on RHS side. Don't write here. Don't write in the subscript or don't add any number to the formula unit. Only take that number ice coefficient before the formula unit. Okay, so in H2O, I need to change the oxygen count. So that's why I need to put coefficient before H2O. So here you are placing the coefficient. Clear? Then I'll put coefficient before H2O to change the count of oxygens here. So here 2 is written as coefficient before H2O. Then check any count changed in the formula unit. So here hydrogens became 4. So RHS side this count became as 4 and oxygen count changed to 2. Okay, oxygen solved. Then what about hydrogens? Count is different. So I need to change the count of hydrogens in H2 where LHS side. So again, I'm going to put coefficient before H2 to change its count as 4. So like this, balancing the chemical equation. Right? So here, is it clear? Is it clear? Right. So we have one more example in your textbook, that is C3H8 reaction with oxygen, burning of propane is giving you carbon dioxide gas and water vapor, right? So this is the reaction. Is it a balanced equation or not? Just verify with your table. So elements, number of atoms, LHS side and RHS side. How many individual different atoms are there on a reactant side? Carbon, oxygen and hydrogen, right? Carbon, oxygen and hydrogen, right? So here simply, sorry, formula written wrong, C3H8. I wrote C3O8 written. That's why you are getting difference. Okay, is it clear? C3H8 plus O2 giving you CO2 plus H2O. So here individual atoms are carbon, hydrogen and oxygen. They are noted in the table elements. Then count carbons. How many are there? 3. Maybe I mistaken the animation. Okay, I'll go without animation here. I made a mistake. Right. Here, count carbons on LHS side. In C3H8, I have 3. In that only hydrogens, how many are there? 8 there. Next, oxygens, how many are there? 2 there. RHS side, carbons in CO2, how many are there? Only 1. Only 1. The next, hydrogens were there in H2O. How many are there? 2. Next, here, oxygens. It is repeated in carbon dioxide and in water. So 2 plus 1, totally 3. Right? They are available in carbon dioxide and also in water. It is. Next, what to do? Balancing. What to do? Balancing. So here, for balancing purpose, you need to copy the same equation without coefficient. C3H8 plus O2 gives rise to CO2 plus H2O. Then look at your table. Here, hydrogens counts different. Hydrogen count different. And carbon count also different. Everything. Oxygen count. Everything is different. So what to do in this case? What I need to select first? Largest compound formula. That is what C3H8. 8 plus 3. Total 11 there. Right? So large numbered compound is selected. Then what to do? Large numbered atom. That is what? Hydrogen. So here LHS side 8, RHS side 2. And that 2 also available in a same formula. That you need to check. If they are in same formula, go for that first. If they are available individually, don't go for that first. Right? Okay. Here 8 is multiple of 2. So how many times? 2, 4 times. I need to write 4 ice coefficient before this, where at 2H2O. So here I am writing 4 ice coefficients. So 4 to the 8, hydrogens became 8. Then change in the count of oxygen. 4 plus 2, 6 it became. But don't write, because I need to balance carbon also. Here, if I change the count of carbon, same as LHS side, 3 carbons, 3 to the 6. Totally here, 6 oxygens. Here, 4 oxygens. It became 10. So, I'll put 5 ice coefficient here before oxygen. Is it clear, everyone? Is it clear? Right? This is trial and error method. You need to reduce your errors by following the logics. Okay, by following the logics. Okay, then we will go for next example here. That is iron oxide reaction with aluminum. Iron oxide reaction with aluminum. So here we have a mistake. Don't see the table that I made mistake. Count is different. Okay, we'll go for third example here. What is third example? That is the reaction between iron oxide with aluminum and produces aluminum trioxide and iron. So this is the equation. Then verify your equation. Is it a balanced one or not? Note down them in the table. Elements, LHS side, RHS side, or number of atoms on reactant side and product side. Anything you can use as your heading in the columns. Then note down the individual atoms. Here iron, oxygen and aluminum. Any other new? Nothing. Then count. Left side I have 2 irons and oxygen only at one place, 3. Aluminum only 1 without any subscription. So where they are, their location also you can note down like this. Next, count of iron on RHS side 1. Count of oxygens in Al2O3 3. Count of aluminiums in the formula Al2O3 2. So note down that location also where they are available. Right? Then balance it. Where the count is differed. So here going for largest number, 2 plus 3, 5 there. 2 plus 3, 5 there. In Fe2O3, 2 plus 3, 5 there. So equal in number. So any compound you can select to balance first. Then large numbered atom is oxygen. They are already balanced. Here see, 3 and 3. Need not to change any count on RHS side, LHS side, whatever it may be, because they are same. Then we'll go for second large or highest numbered atom, that is iron or the aluminum. So here 2 and 1. So 1 into 2, the problem will be solved. Here 1 into 2, the problem will be solved. So I wrote 2 ice coefficient before iron, where product side. So that same I can put ice coefficient before iron. Here 2 ice coefficient before aluminum. Okay, so we can write here. I already shown in the table, right? where we need to write coefficient before the formula, right? So table advantage is there. If you write composition like this, automatically you will get idea where you need to write that coefficient particularly in your equation. Is it okay, this logic? Is it helpful? Writing the location, right? So directly I can use this coefficient to before iron oxide. Then here, sorry, wrong. Here I changed the coefficient. This coefficient will be written before iron, right? Then coefficient aluminium before aluminium, we can write here. Harshit,
Sir,
raise your hand. Any confusion?
no,
Okay. So are you clear how to balance easily without any confusion using the table? Using the table. So easily you will find the location to put your coefficient. Okay. So follow this logic while balancing in your rough one. So we can put coefficient 2 before Al and before iron. So easily it is solved. Right. So with this example, balancing of chemical equations topic completed. Are there any doubts in the balancing? Are there any doubts in the balancing? Go to quick reaction. If there is any doubt, ask me immediately. No doubt. I'll give you one example. Try to solve it. I'm giving you one example here. That is reaction of ammonia and H3 NH3. NH3 and NH3 reaction with chlorine gas to produce N2 and NH4Cl. Can anybody solve? Raise your hand. Raise your hand. I'll give you the chance to solve this on the screen. Raise your hand. No one? Okay, Rohit. Just try to write on your screen. I'm giving you access on your mobile screen. Balance it. Just write on your screen. Your chance. To written as coefficient before NH3. Okay. Can anybody, Rohit, why you written 2 as coefficient before NH3? Answer me. Why you written 2 before NH3? 3 written, again changed. Okay, trial and error method. Okay, go on. Okay, nitrogen count is same. LHS side, RHS side. Then what about the other disturbed atoms? Okay, 4 is taken. 4 plus 2. Sorry, 4. 4 plus 4. Okay, right. Again changing to 3. 3 plus 2, 5. Nitrogens are different. Nitrogen's count is different. Right? So is it confusing or not? What about remaining members? Are you facing the same problem? Are you facing the same problem? Did you got answer? Medashri, Surajita, Vikrant, Harshit, Tejaswini, Abhinay, Sricharan. Have you got answer? It's not much difficult, but you are making difficult. You are only making difficult. Are you following the steps? Are you following the steps? Respond me after completion. I'm waiting for your response. Raise your hand who are completed. If you completed, just raise your hand. Shall I start explaining? Shall I start? At least respond to me. Am I audible? Shall I start explaining? Yes. Sricharan, what happened? Why you are not able to solve this one? Can you raise your problem?
Atoms count changing, sir.
What happened?
Atoms count is changing by adding coefficients.
So by taking coefficient, you are unable to solve the other. One atom may be solved, but it is difficult to solve another. Yes or no? That problem you are facing maybe. Rohit, Abhinay, same problem. Vikrant, Harshit, same, facing the same problem? Yes. Right. So here, in this case, just follow my steps. What I said, first selecting the largest formula unit. Okay, so 1 plus 4 plus 1, totally 6 atoms there in the different atoms in the same formula, right? Then, sorry, second step. What is second step after completion of this one? After completion of this one, second step, selecting the highest numbered atom. Which is highest numbered atom? Which is highest numbered atom? It is
Sir, H4.
hydrogen, right? So I try to solve first hydrogen. How many are there here? 4. How many are there here? 3. Then take the cross product. 3 and 4. What it will give you? 12. So you need to make the count of hydrogen size 12. Right? You need to make the count of hydrogen size 12. Sir, already I did, sir. Okay, here 4, here 3. What happened? What happened? Tell me. Again, I am facing the problem. What is that? Count of nitrogen on LHS side given by 4 is 4. Coefficient 4 giving you nitrogen count is 4. Then RHS side, here coefficient 2, 3 placed. Here nitrogens became 3. Here 2 there. 5, sir. Again, it is not balanced, sir. Okay, I will accept. Then what to do? Here just you need to double what the coefficients you decided. What you selected actually? 4. and 3. Then go for double immediately. Right? 6. Then 8. Now try with coefficients. 8 here, 6 here. Now check the count. Sorry. Here left side 4, left side 4. Right? Here 3 there. I selected 4 here. I selected 3 here. Not that coefficients. Right? Count of atoms are 3 and 4. Here its coefficient previously I selected 4. Previously I selected 3. That I am making double. Ice 8 and ice 6 here. So now write the coefficients before the formula unit. NH4Cl coefficient written 6 and NH3 coefficient written 8. Just I doubled the previous numbers. Then now look at count of hydrogen 6 4 24 on RHS side. Here left side 8 3 24 on LHS side.